Section 1.2, Linear Inequalities. In the first video for this section, we will review the inequality symbols, learn how to graph inequalities on a number line, and how to write them using interval notation. So we'll start by reviewing the symbols. On this slide, the first symbol you see is the less than symbol. If we're reading from left to right, this symbol points to the left. That may help you remember less and left. So less than points left. The symbol below that is greater than. It points to the right. So the open part will be towards the bigger number. The symbols on the right side, you'll notice, have a bar underneath. That bar means or equal to. The key word there is or, and I'll show you why here in just a second. The next part of the slide says that basically we're going to use parentheses when a number is not included and square brackets when a number is included. So you'll want to remember that parentheses are going to go along with less than or greater than without the bar. The square brackets will be used when your inequality symbol has the equal to bar on it. Let's look at an example. Let's say we have x is less than 5. So just like with equations, a solution to this inequality is any value of x that makes that statement true. So certainly we could list some solutions. Maybe you're thinking 4. 4 is less than 5. It's a solution. We could, of course, do 3, 0. We could do some negative numbers. We could do even fractions. 1/2 is less than 5. There is actually no way that we could list all the solutions. There are infinitely many. We could even include 4.999. So we need another way to show the solution set without having to list all the solutions. Now, what about the number 5? Would 5 be a solution to that inequality? Well, let's substitute 5 in for x. It says 5 is less than 5. That is not a true statement. That's false. So 5 is not a solution. It would not be included in the solution set, which means it would get parentheses on it. Now, if I changed it to x is less than or equal to 5, and then we substituted the 5 in for x, that is a true statement. True statement. When we read it, it says 5 is less than or equal to 5. The or indicates it just has to be one of those. So here it would be the equal part that makes it true. And for that inequality, 5 would be a solution. It would be included, and so it would have square brackets on it. Over here, 5 would have parentheses on it. So let's see, where are we going to put those parentheses or square brackets? But one more thing, there's one other statement on here. A lot of information on this slide. Infinity and negative infinity will always have parentheses. And that is because we don't ever actually reach infinity. We get closer and closer, but it's not included. It uses parentheses because we don't equal infinity. So here's the inequality we were just looking at. X is less than 5. So we want to graph that on a number line. Since we can't list the solutions, we're going to show them with a graph. So you're just going to draw a horizontal line, put some arrows on the ends and put a tick mark right on the line in the middle. Whatever number is in your inequality, you're going to write that number under your tick mark. If you want to write some numbers to the left and right, you are welcome to. I do not require that you do that. Next, we're going to shade where the solutions are. So look at your inequality. X is less than 5. So the solutions are all the numbers left of 5. So I'm going to start at 5 and just shade. Or you can just do a squiggly line like I am, or kind of shade it in with a different color if you want. Pass the arrow, because that indicates it's going to continue going forever in that direction. All of those numbers are solutions. Now, what about 5 itself? We talked about that it is not a solution here, and to show that it is not included, we will use parentheses, and you're going to put those right directly on the tick mark towards the shading. If I can do that here. Sorry. Should go right on the tick mark. This is not the best, most accurate way to write here on the screen, but hopefully you get the idea. We're shading to the left. We've got our parentheses on the tick mark open towards the shading. And you definitely want them right on the mark. You don't want them to the right or the left of the mark, because then you're either leaving out solutions or adding ones that shouldn't be there. So try your best to get it right on the tick mark. Let's go ahead and we'll continue graphing, and then we'll come back and talk about the interval notation. So second graph, draw another line with the arrows, put a tick mark in the middle. And this one has a fraction. That's okay, it doesn't matter. You just write that fraction below your tick mark. And I'm going to change colors for the shading. Now, if I read this inequality from left to right, it says x is greater than or equal to 1/3. So the solutions are numbers greater than 1/3, so I'm going to shade those, which would be to the right. Shade up. 1/3 is a solution because of the equal to bar. X can equal 1/3. So to include it, we would use square brackets right on the tick mark, open towards the shading. So now that shows the 1/3 included in the solution set. Notice on both of those examples we just did, the shading is towards the direction that the symbol points. On the first example, the symbol points left and we shaded left. On the second example, the symbol points right and we shaded right. As long as your variable is on the left side of your inequality, that will always be the case. Okay, our last example is a little different. I'm going to draw a line again. It is called a compound inequality when x is in the middle. You've got two numbers, so you're going to need 2 tick marks on your graph. Always put the smaller number under the left tick mark. And when you read a compound inequality, it's easier to read from the x than trying to read it left to right. So if we read from the x, it says x is greater than or equal to 1 and x is less than 4. This is an and statement. X fits both, greater than or equal to 1 and less than 4. So you have to find the numbers that are both of those, greater than 1 and less than 4. So that's all the numbers that are in between 1 and 4. Now, greater than or equal to 1. X could equal 1, so 1 should have a square bracket. Sorry, I'm having trouble getting that right on the mark. Square bracket towards the shading, and 4 is not included. There's no bar on that side, so the 4 should have parentheses towards the shading. So that is how you graph the solution set on a number line. Now, you will also be asked to write the interval notation. Interval notation is always written left to right. You may think of it as left to right, or you could think of it as small to large. Must be in that order. The order is important. So you're going to look at your graph. I think that's the easiest way to do it. And find your leftmost value that is shaded. Well, on our first graph, we shade forever to the left. So we're going to show forever to the left as negative infinity. Okay? Negative infinity means forever left. And then our rightmost value, you're going to put a comma. So it's left to right, but it's left comma right in our interval notation. 5. 5 is our rightmost value. Now you may say, well, 5 is not a solution, and that is true. However, I cannot pick that biggest number that's less than 5. You know, would it be 4.99 or 4.999? I could just keep putting more 9s and never get to that biggest number that is a solution. So you go ahead and put the 5 and just show you're not including it with the parentheses. And remember on the previous slide we said infinity and negative infinity will always have parentheses. So that's what the interval notation would look like for that first example. On the second example, again look at your graph. Find your leftmost number of the shaded region, which is 1/3. And then you put a comma. And your rightmost, well, it goes forever to the right. We're going to use positive infinity, meaning forever to the right. Keeps going forever to the right. So put a positive infinity. And again, infinity will always have parentheses. The 1/3 in this case will have a square bracket because we're including it. On the third example, again, the leftmost to the rightmost of the shaded region. Well, our leftmost number is 1. We put a comma. Our rightmost number is 4. We're including the 1, so square bracket, just like is used on the graph, and not including the 4, parentheses. And that would be the interval notation for your third example. If I were to ask the question, how many numbers are in that interval from 1 to 4? You may be tempted to just count your whole numbers, 1, 2, 3, 4. But there are infinitely many numbers between 1 and 4. And we could go back to decimals like we were looking at earlier. We could say, well, 1.01 and 1.001, 1.2345 is in that interval. And we haven't even gotten to 2 yet. So infinitely many numbers even in that solution set. Let's practice. The instructions say graph and write in interval notation. I always like to do the graph first because to me I find it easier to use the graph then to write the interval. So just draw your number line. Put your tick mark, Put the 8 underneath. Put numbers to the left and right if you would like, but you do not have to. So I'm going to stop for just a second and let you guys try to complete that graph. Okay, let's see how you did. N is less than or equal to 8, so you should have shaded left of 8. Equal to tells me that I'm including 8, so you should have a square bracket on the tick mark open towards the shading. So that's what your graph should look like. And then for the interval notation, left to right, so forever to the left, we need to put negative infinity first, comma 8, parentheses, and then a square bracket on the 8. So now we have the graph and we have the interval notation. Go ahead and try number 2. See if you can do both the graph and the interval notation. Let's see how you did. So number 2, y is greater than negative 3. You should have shaded to the right, not including, because there's no equal to bar, you should have parentheses on the negative 3, open towards the shading. Then for the interval notation, left to right, so left value is negative 3, comma, forever to the right, we show with positive infinity. Parentheses we're not including, and infinity will also get parentheses. And then our third example. Remember, to read a compound inequality, you want to read from the x. So if we read from x, and then we read this open part of the symbol, that means greater than. So x is greater than negative 4, and x is less than or equal to 2. Greater than negative 4 and less than or equal to 2 is in between. There is no bar on the symbol next to the negative 4, so we're not including negative 4, parentheses. There is a bar next to the 2, so square bracket. And it doesn't always have to be one parenthesis, one square bracket. Sometimes they might both have bars, sometimes neither will have bars. Now for the interval notation, leftmost value negative 4, rightmost is 2, and again the parenthesis and the square bracket. So that is how we are going to write the solution sets when we solve linear inequalities. And we will look at the steps for solving those in the next video.